Hi, all of you. Is my sound is audible? Okay. So today we are going to start with the Git. Okay. So all of you created the GitHub account, or anybody is still to do that? Okay. So let's start with the Git. So if you'll try to search about the Git on the Google, right? So you're going to get two answers. Either somebody will write it as a software configuration management, or somebody will write it as a source code management. Okay. So what is the software configuration management or source code management? So basically, we know that all the developers are going to write the code, design the website, right? So for designing the website, designing the application, you have to write the code. Okay. Now to write the code, you have to write the code in your personal laptop, right? But when you are writing the code in the personal laptop, that doesn't mean like you are only the person who is writing the entire code. Like if I talk about the Flipkart website, Amazon website, right? These all are the big websites. So if the developers are writing the code for this type of the website, so definitely there are the multiple developers will be in the team. Okay. And if multiple developers who are working on it are there, okay, so you cannot keep all the codes in your laptop because other people also have to see the code, right? Other people will be also contributing in that code. So we'll require some centralized location, okay, where both the people will have the access. Like the as in, if there are two developers, so developer one will also upload their code to that particular location. Developer two also will be uploading the code to that particular location. So they will be able to read to each other code. If they will be able to read to each other code, then only they can contribute and they can develop the application. Okay, so this was the thing. So when multiple developers will be working, some will be working on the logging page, some one is going to work on the payment page, someone will be working on the add to cart page, like that way. Okay. So basically every developer will be writing the code separately, okay, for the task, whatever the task assigned to them. Okay. So previously what was happening was when there was no Git or there was no source code management tool was available in the market. Okay. So for adding the code of the different developer, we have to do it manually. Like manually, manager have to call to each developers that have you completed your login page code? Can you send it using email or something? Okay. Similarly, with the developer two, developer three, it was time taking process also, and it was the hectic job for manager to keep asking for every developers, right? Have you completed your code? What is the update? Like this, all these things. Okay. So managing manually was literally difficult. So people thought that, okay, let's come up with some solution which can automate this entire process. Okay. And there people come up with the idea of the source code management tool. Okay. So Git is not the first tool which came in the market to do the source code management. Okay. This is the first thing you have to understand. Git is the later tool. Okay. That came later in the market. Previously, there was one more tool available in the market that was quite popular. Okay. So when the source code management tool they were started to develop, okay, so the first source code management tool developed in the market was the centralized version control system. Okay, this is the previous generation. Example was SVN tool. Okay, now the after that another tool got created, distributed version control system. Okay, and example is Git. So Git is always comes under the distributed version control system. SVN comes under the centralized version control system. We have to see the difference between these two, right? Like what is the difference between centralized version control system and difference between distributed version control system, and why the distributed version control system came later? Because there will be something limitation will be there, right? That centralized version control system we are facing some difficulty. To solve that difficulty, this distributed version control system came in the picture. So these all things we'll try to understand. So first, let's try to understand the centralized version control system. In the centralized version control system, what they say is, okay, take an example. There are two developers who are working, one from the India, another from the US employee. Okay. So when there was no tool available, that time what they have to do? So Indian employee will be uploading the code. Okay. He will be writing the code in his laptop. When the US employee is going to call him that, can you send your code, whatever the code you written? Okay. So to the US employee, this Indian employee is going to send the code using email or some messaging tool, something like that. Okay. So this was a hectic job for every day that US employee have to call to get the code. Indian employee also have to. to call to them, right? Whatever the US employee written the code to get that. So to solve this problem, centralized version control system came in the picture, where they say that what we can do is whatever the Indian employee is writing the code or the US employee is writing the code, okay, rather than saving the code in their personal laptop, because they are saving it personal laptop, that's why this US employee is not able to read the data of this person, this Indian employee is not able to read the data of this US employee. So what we'll do is whatever the Indian employee will write the code, they will update the code or they will commit the code to this repository. Okay. What is this repository? This is just like a centralized location. Okay. Centralized server, you can say, or a remote server, you can say. Okay. Or you can simply say that this is just a storage location. Okay. So in a office, there is a bigger centralized servers we created. Okay. And where all the developers in the company is working, they will be uploading their code in that particular central server or remote server. Okay. So whenever this Indian employee will write the code, they will commit it, they will upload it to this repository. Whenever US employee will require that particular code, he will update that code from this repository to his laptop like that way. Okay. So now they don't have to manually call to each other. Okay. They will always go to this repository, they will upload the code, latest code, they will download the latest code, everything they can do it from here. Okay. So everything was good, problem was solved. Now the people don't have to call, everything is getting managed, right? Because all the employees are going to upload their code to this repository. Whenever somebody want to read the code, they can just go there and read it also. But then what was the two drawbacks? Okay, basically there are two drawbacks in the centralized version control system. Okay, due to that we moved to the distributed version control system. Okay, so what are the two drawbacks in this setup? The first drawback is it is slow. Why it is slow? Because see, this is a repository, right? So this is a remote server, okay, and this is your personal laptop. So just think like this: if there is a storage that is kept at some different location, right, and you have your personal laptop. So if you want to upload some data from your personal laptop to that particular remote repository or remote server, do you require anything to do that? Anybody can think of? Like there is my personal laptop and I want to store some data in some hard disk that is located some different location, okay, that is computer connected to some different computer machine. So how we are going to upload our laptop data to that particular storage system? Anybody can understand like this? Think of anything? Do you require any type of the connectivity or something to do that? Yes or no?
Yes, we need the connectivity.
We'll require that internet
Yeah.
connectivity, right? Then only we'll be able to reach there. So that means these two persons should always be connected to the internet. Okay, then only they will be able to access the data. If internet is down, they will be not able to do anything. Okay, and that was the first drawback. Because the code is not locally available, meaning you always need to be connected to a network to perform any action. Okay, and currently you will be thinking then what is the problem in the connection of network? Okay, why it will be slow? Okay, we are in the 4G 5G world, but that is not the case. We are talking about back in 1990s, 2001, something like that, right? That time, you know that what was the internet speed? It was in the kbps, literally, right? So that time, if somebody is going to upload 20, 25 MB of code, okay, to some different repository or something, it was a headache process. It will be so slow. People are totally dependent. If something connection lost in between, developer have to just keep sitting because they cannot store their code in personal laptop. They are reading and writing directly from this repository. So if their internet will work, then only. So if they are committing something and internet is slow, then definitely this response time is going to be slow. So that is the first drawback. Second drawback is since everything is centralized. So if central server gets failed, you will lose the entire data. Because all the developers are uploading their code to this repository only, and due to some problem, this remote server crashed or it got shut down for a few hours, right? Or it lost the data, then entire company is going to be affected. All the developers, everything, because everybody is storing the code here only, right? And if something wrong will happen, everybody is going to lose the data. So that was the two drawbacks. Okay, the first drawback, we should always be connected to internet. Second thing is a single point of failure. Okay, that means as soon as remote server is going to be failed, okay, entire data will be lost. And example of this tool was the SVN tool. To solve this problem, distributed version control system came in the picture. Okay, and the person who developed it as the Linus Torvald. Okay, the same person who developed the Linux also. Okay, So he developed a tool and named the tool. Just give me a second. Okay, he named the tool as Git. Okay, so how he solved this two problem? His goal was to solve this two problem only, that network connectivity should not require every time. And second thing, if something is failed, okay, like remote server is failed, then we should not lose the entire data also. Okay, because he developed the Linux and multiple people started to use Linux, so he don't want to lose his data everything. Okay, that's why he developed his own tool. And when he developed the tool, he said that let's do with this type of the process. Here, see this working space. This is just a personal computer of the some employee. Okay, like take an example. This is the code of laptop of the Indian employee. This is the laptop of the US employee. Okay, working space. Working space is basically a directory of the Indian employee. Basically, in the Indian employee laptop, there is a directory or basically a folder. Okay, that we see it as a working space. This working space is basically belongs to the US employee directory, okay, or US employee folder. Now, what we are saying is all the developers who is going to write the code, they will save it in their working space. They will be keep everything. They will be doing it in their working space only. They will be writing the code, everything. Okay. Once they write the code, they completed their code, right? So they have to commit the code. Here also you are committing the code only, if you'll see. Here also you are committing the code, but you are committing the code directly to the repository, central server. Okay. But here we are saying when your work is done, what you can do is you can commit the code in your local repository only. That means you are saving it in your local laptop only. In a local laptop only, there is a folder inside that you are saving all the data after writing the code. You are writing the code, you are saving it in the local repo. You are writing the code, you are saving it in the local repo. Something like that. Okay. Once your work is done, take an example, in the entire day, I completed 10 codes, okay, 10 files of code. So all the codes I created in the working space and I saved it in the local repo. That means in my local directory. Okay. Now, if I'm saving all the data locally, okay, so that time, do we require any internet? What do you think? If we save any data, any file in my local directory, in my D drive, E drive, something like that, do you require any internet to save that?
No.
No, right? So that means at this stage, we are not requiring the internet. At the last, okay, at the last, like my work is done, entire day, my work is completed. Okay, now I want to leave the office. So before leaving the office, what I'm doing is I'm just running a command called git push. Git push is something like upload. Okay, so we are uploading the code to the repository. So during this process, do we require internet? If you're going
Yes,
to
we do.
upload something, yeah, so we'll require the internet at only fixed interval of time when we are uploading the code. Okay, we don't require the internet for entire day. So this problem is sorted, that we should not be connected to the entire day to the internet. And since we are not connected to the entire day to the internet, so that's why when we are committing the code, when we are updating the code from the local repo, it will be faster. Because if I'm going to play video from one of my drive, so it will be faster as compared to playing the video to go to the internet and playing from some website, something like that. Okay, because there we are totally dependent on the network speed. But when we are uploading it, that time we'll definitely require the internet. Okay, once we uploaded the code to the repository, then my work is completed. I went to home. Okay, now the US employee is coming to the office. Okay, because his time zone will be different. So what he will do is he will not start to write the code directly from the working space. Okay, because he know that Indian employee definitely done some changes in entire day, right? So what he is going to do is he will pull the code. Pull the code is basically download the code from the repository. So this time again he will require the internet. Okay, but once the code is downloaded, okay, then again he can start to work parallelly, right? And he will update some changes, everything in the entire day. And again, when he will be leaving, he's done with his work, he will upload the code again to the repository. That means both the problem is solved. The first problem, we should always be connected to internet. That is also solved, okay? Because we require internet for few times only, okay, when we are uploading and downloading, that's it. All other process, we can do it without network connectivity. Second thing, if something wrong happens with this repository, okay, if something wrong happens with the repository, do we lose the entire data? What do you think? Anybody? Will we
Yes,
lose? Will
yeah,
lose?
yes.
Just try to understand here. Like if you are uploading something to the Google Drive, right? Take an example. I uploaded this file here to the Google Drive, right? But the
Yeah,
copy of this file is present in my directory also, because from there only I'm uploading it. Making
yeah.
sense?
Mm-hmm.
So that means even if this file will be deleted from here, I can again upload it from here because I have the local copy. Okay.
Mm-hmm.
That means when you are uploading the code, okay, when you are uploading the code, where is it? When we are uploading the code, right, to the repository, we have one copy at the local repo also. So even if this is got deleted, so definitely one copy both the employees having in their personal laptop also. Because whenever you are uploading and downloading, you are storing the code first in your directory, then only you are uploading it, right? So even if something wrong will happen, we'll have a copy of that particular code in my local repo. Similarly, US employee will also have their changes. Okay, so in a company there are 10 employees, 15 employees is working, so all the 15 employees going to have the copy of the code in their laptop, right? That means in the worst case scenario we are not going to lose the entire data in a single go. But in that particular problem, people were not storing the code in their laptop locally. Okay, so everything was dependent on the repository. So if repository was down, they cannot do the work. But now if the repository is down, this developer can still write the code and upload the code, everything. Okay, just the only thing, he will be not able to upload it to the repository, or he will be not able to download it from the repository. But writing the code and saving it in the local repo, he will be still able to do it. That means work will be not hampered. Okay, and once again, it is something like this: in the entire day you are doing all your work. Whenever you are getting the internet connectivity, that time you are uploading the videos on the YouTube or something. Okay, and this is the usual process we do. We edit the videos, everything locally. Okay, and whenever we get the good internet connectivity, we upload the videos to some different Google Drive or whatever we require, right? So that is the exactly same things happening here. So hope this is clear to you.
Yeah.
Any confusion in this? Okay, and since Git was created by the Linus Torvald, so he designed the Git to works on the Linux kernel only. Okay, and Git is nothing, just a software. And these things again I explained you already, that in distributed version control system, every contributor, that means every developer, has a local copy or clone of the main repository. Okay, and that's why even if the something happens wrong with the main repository, all the people will having a local copy of that, so there will be no any problem in that. Okay, and Git help us to maintain the version of the code. Okay, what is the version of the code basically? So see, every time you are seeing that update is coming on the WhatsApp application, right? But do you think that whatever the update is coming, that is definitely coming from the new code, whatever the new code they added, right? But that doesn't mean they are deleting the previous code, because we don't know, when we updated some WhatsApp application, maybe it is not working something. We also complain also sometimes that we updated the application, now this feature is not working because there is some bug in that. Okay, that's why they require to store all the previous versions code also. Okay, so that can be easily helpful in both the SBN tool and Git tool. Both are helpful in that case. Okay. Now, if we'll see the difference between these two tools. So in the SVN, client get local copy directly from the server. In the Git, every client have the local repository in their laptop itself. SVN is easy to learn and set up because it is not complex. Okay. Git is little bit complex. It is difficult for beginners. Okay. Multiple commands you have to remember because Git provides you so many extra features also. Okay. You cannot get the offline access in the SBN tool, but Git can works in the offline access also. Okay, just only one things you will be not able to do, that is upload and download. Else all the things you can do in the Git even without network access. Now, SBN was slower. Why it was slower? Because it was totally dependent on your communication with the server speed, that is your network speed. Okay. This is faster because everything we are saving it locally, right? So when we are downloading and uploading everything locally, okay, so it will be definitely faster as compared to reading the file from some different website or some using the internet or something. So once if difference is clear, okay, now we are going to try to understand the stages of the Git or workflow, how actually Git works. That we'll try to understand one by one. Okay. So this is again mostly theoretical part only, but whatever the part I am explaining now, okay, that stages of Git or workflow, okay, if you'll explain and if you'll understand this entire explanation, okay, so it will be easy for you to do the practical, okay, and to do all the commands, everything will be able to learn easily, okay. So just try to focus on this. Let me just do one thing. Okay, so just give me a second. Let me explain you the entire workflow. Anybody have you heard about the Git workflow, or all of you are totally new?
And
You know?
I'm new actually.
New. Okay. Anybody others than that? Okay, then I assume everybody is new. Okay. So all of you are aware about that directory part, right? That we can create a directory in any Windows machine or Linux machine. All of you know that, right? How to create the directory in Linux also, you know, using the mkdir command. In Windows also, you know that you can create a new folder. Okay. So the first thing what we are going to do is, okay, we'll be creating a new folder, something like this. Let me just show you. Okay, we created a new folder. Okay, so this is just a new directory we created. Okay, nothing else. Now, to create a new directory, you know what is the command. What is the command? If we
Maven.
talk about for the Linux directory, mkdir, right? Right?
MKDIR.
Mkdir, take an example, we created directory with the name called code workspace, something like this. Okay, we created a directory with this name. Now to go inside this directory, what is the command? To go inside this directory, what is the command? cd, right? Cd was the command to go inside that. I forgot. To go inside any directory, we were using the command called cd. Okay. Now, when we came inside this directory, so currently this is a normal directory, right? This is not treated as a Git repository or something because your Linux is going to understand, okay, this is a normal directory. You are going to use it for normal purpose. But Git say, okay, Git say that if you want, okay, if you want that this will be treated as a special repository or local repository, then after going inside this directory, you have to hit a command called git init. Okay, git init. What is going to happen is as soon as you are going to hit the command called git init, this repository or this normal directory will be changed into as a local repository. Okay, so flow will be something like this. As soon as you are hitting the git init command, a new box will be created, something like this. You'll be not able to visualize, but just this is the explanation what is happening in the backend. Okay, this is not the thing like you will be able to see in the backend. But whenever you do the git init, a new box got created. Okay, and inside this box there is a 3 partition comes. Okay, something like this. Okay, hope this is clear. Now inside this 3 partition, the first box, this box, okay, this box is going to known as a workspace. This box is known as a staging area. This box is going to known as a commit area. Or some people say it as a local repo also. Is this thing is clear that as soon as I'm going to do the git init command, these 3 things happen in the backend? All of you?
Yeah.
Okay. Now once we done this, now the question is what are the things we do in the workspace? Okay. So basically, when in the git init, right? When you done the git init, right? So they will say that your git is this directory is initialized as a git repo. Okay. Once this is initialized at a git repo, okay. Now they will say you that whatever the files, whatever the code you want to write it, you can just write it inside this file. So using the cat command, vi command, nano command, whichever the editor you are comfortable with, okay, you can create multiple files here. Okay, so take an example, somebody created a file with the name called a.txt, okay, b.txt, c.java file. So whatever the code you are going to write, you will be writing in the working space only. Always make sure, okay? You cannot write the code in the staging area or commit area. Whenever you are writing the code inside this directory, that will be automatically written inside the workspace only. Okay. So working space is a place where you are going to write the code. Now, after writing the code, I done my work, my everything is completed. I don't want to do any changes in this code. Okay. Now, what they say is, if you're done with all this work, let me just do one thing. Okay. Once you're done with this work, your code is completed. Okay. Then you have to move these all three files to the staging area. You have to move all these files to the staging area. How to move all these files to a staging area? You have to use a command called git add. If we'll use the command called git add and then the file name, okay, so what they will do is they will move these files to the staging area. And once the file comes in the staging area, okay, then you cannot edit the file. You cannot edit the a.txt file, b.txt file, something like this. If you want to edit it in the working space only. Once your work is completed, then only move the file to the staging area. Once your file is come to the staging area, then it is freezed. Okay, you cannot do any further changes. And after staging area, you have to move this file to the local repository. That means we have to save this file locally. Okay. So to do that also, to save the file locally, you have to hit a command called git commit. As soon as you are going to do git commit, your file will be moved from the staging area to the commit area. Okay. And since your file is moved to the commit area, that means it's saved locally. Now you saved the file locally. Okay. And whenever you hit the git commit command, a commit ID generates. Commit ID is a unique character, okay, 40-digit character basically, 40 digit. This character generates, okay, every time. Whenever you will hit the git commit, a new commit ID will be generated. And this commit ID is only helping you to check the versions, everything, okay. If somebody is going to update the code, right, so a new commit ID will be generated. That means this is the new version of the code. So like that way you can understand. So what we done, we written the code in the working space. We use the git add command to move the code to the staging area. Then we use the command called git commit to move the code to the commit area or local repo. Once we saved our code locally, then what is the next thing we have to do? Anybody? After saving the code locally, what was the next step we were doing?
Move it back to staging area.
Why so? See, once you saved the file locally, right? Take an example, I edited a video file, right? Locally. Then what is the next thing we'll be doing? We'll be uploading it, right, to some of the Google Drive or YouTube or something like that, right? So similarly from here also, now you are going to upload the code, now getting it, okay? And where you will be uploading this code now? Remember, you created an account, GitHub, okay? GitHub is nothing, just your repository, central repository or remote server, okay? So GitHub is nothing, just like a Google Drive. Making sense?
Yeah.
And how to upload the code here to the GitHub? For that, you will be hitting a command called git push. It will upload the command from the commit area to the GitHub. Okay. Once the code is uploaded to the GitHub or central location, like some file is uploaded to the Google Drive, and if somebody want to use it, so what they will do? First they will download it. Making sense? Git pull. Right? If somebody want to use this code that is uploaded to the GitHub, they will do the git pull. But before doing the git pull, what they will also do is, okay, what they will also do is, let me just create. They will also create a directory, okay. And inside that directory, they will also hit the command called git init. So automatically 3 partition will be created. Okay. And here also the flow will be same only. This one will be known as the working space. This will be known as the staging area. And this will be the commit area. So whenever they are going to do the git pull, so what is going to happen? This code is going to be saved in this commit area. Okay. Once the code is saved in the commit area, so they will be visible in the working space also. If they want to do some changes in the file, they will do the changes in the file in the working space only. Okay. They are going to change, like take an example, this US employee is going to change the file in the a.txt file. He will do the changes. After adding some extra line inside this file, he don't want to do any further changes. Again, he will move the code to the staging area using the command called, remember the command? To move the code from working space to a staging area, what was the command? Git, anybody?
Add.
Git add. Okay. Similarly, to move from a staging area to commit area, what was the command?
Commit.
Git command. Now, once the code is moved to the commit area, again the updated code is saved in the local repo, right? But whatever the update, some of the code we done in the a.txt file, that is not visible to this particular person, right? So what we have to do? Again, we have to upload this code also to the GitHub. Making sense? Using the command called git push. Now the updated file is updated here. Okay. Once the updated file is updated here, now this person is going to do the git pull. So he will get the latest code now. Okay, so whatever the changes he done, he will get everything in the local repo. Again, he can read the file in the a.txt file. So this will be your entire flow. So just see this flow. Okay, I don't know you are able to see everything in a single screen or not. Okay, but see this flow. Okay, and just try to tell me that if anywhere you have any confusion in this.
Why there are two? For example, there is Git and GitHub, right? So in Git, there is a working space and staging area and commit area, right? And
Okay.
what is the difference between Git and GitHub?
GitHub is a central storage. That's it. GitHub you can compare with a Google Drive. What are the things you upload in the Google Drive? The videos, images, right? Similarly,
Yeah.
in the GitHub, you only upload the code there. That's it. That is the only difference. But it is just like a Google Drive only. Whatever the service Google Drive is providing you, exactly same service GitHub is providing you. Okay. So take an example, just think like this. You have to share some movies with your friends, right? So what you can do, either you can upload the video movies to the Google Drive or you can upload it to the Dropbox, right? And you can share the link, you will be able to access. Similarly, we can upload the code to the GitHub and I will give the link to my other person and he will take the code from that location, like that one. Okay. And similarly, whatever the changes he is going to do, he will also upload to that GitHub. Okay. And from there, we'll be pulling it like that way.
Okay.
Oh. See, basically, this is our GitHub account. Let me show you one GitHub account. So basically, see, these are the repository, right? So inside this repository, whenever we are hitting the command called git commit and we are doing the git push. So when we are doing the git push, we have to tell, right, that which repository we are going to upload the code. Repository is like multiple folders. In the Google Drive also multiple folders will be there where you will be uploading the movies. So I'm saying that you have to upload the code in the simple web server. So whatever the code I will write, like I written the index.html file. So that file will be uploaded here. Okay, that file will be uploaded here. If somebody is going to do some changes, again, it will be reflecting here. And when somebody will check the history here, so they will be easily able to see that when some people done some changes. There is some changes happen at this time, somebody done some changes at this point. Whenever you will click on this box here, you can easily see what are the changes they done. See, they are saying that previously the color was orange, right? Now they changed that color to the red. It is highlighting these 2 points. Making sense? So that means this is the changes you done. And by seeing this, anybody can say, okay, US employee changed the code here. Like that way. Manager can also verify what are the changes they are doing. Similarly, if you'll see at this point, what is the error here? So they are saying previously the color was green, you change it to the powder blue. Again, they are highlighting it. What are the changes you've done? See, red color means you deleted that line, green color means you added that, plus, minus. Okay, this one. So like this way we can understand here. Okay. And let me show you one repository. Again, this repository part will be clear when we will start to upload the code to the GitHub. Okay. Till then, just focus on the flow. Okay. And the flow is basically, we'll be writing the code in the working space. then moving it to the staging area, then move it to the commit area. If you will ask me, can I move directly the code to the working space to the local repo? No, you cannot do that. You have to move to a staging area, then only you can commit it. Once you save the code locally, then only you can upload the code to the GitHub. Okay. But in SBN tool, what was happening was after writing the code, we are directly uploading it to the GitHub. And since we are directly uploading not to the GitHub, basically the SBN tool storage. Okay. And since we are uploading directly to there, so the problem was if internet connectivity was not there, we'll be not able to see the code. But here we are saving the code locally also, so we can easily see it. So that is the benefit. Any other question in this flow?
So once the code is in the commit area of the GitHub, that means it is ready for the deployment?
Not deployment, it is ready to upload.
Upload, I mean, okay.
Yeah, see, deployment is very later stage. Now you are just writing the code here, right? After that, you have to build the code, you have to test the code, right?
Yeah.
So these are the entire process. Deployment is the last stage. Currently, we are just writing the code. Okay.
Gotcha.
Any other thing, anybody? Okay, so I will upload this document. Okay, this theoretical document. So what you have to do is just go through this document. I will upload this Git file. Okay, in the PDF format. So here also I explained here that whenever you do the git init command here, so basically this three box got created: working space, staging area, local repo. Okay, now to move the code from working space to a staging area, you know the command git add, staging area to local repo git commit. After moving the code to the local repo, we have to do the git push, then it will be uploaded to the GitHub. Then somebody will do the git pull, code will come to another person's laptop. Again, they will start to do the work, working space to staging area using the command called git add, then git commit. Again, they will upload it using the command called git push. What is the working space? This is the place where we write the code. What is the staging area? This is the place where we freeze the file, okay, which we want to commit it or which we want to save it. Local repo, where we save the snapshot of the code. That means we save the code locally. So these all are the things, okay. So just try to go this line by line, okay. Read up to this particular line, working directory and this node part, okay. So up to here, if you'll read now, like what is the commit, everything, this is all the theoretical things, okay. After push and pull from the branch, again I will teach you, okay. But this and pull operation, everything I just shown you, okay. That from the local repo, when we'll do the git push, whatever the changes we done here, that will be uploaded here. When we are doing the git pull, so whatever the changes are uploaded here, that will be downloaded in my local repo. These all things, just try to read it and understand it, okay. And tomorrow when I will start to set up the practical, okay. So we'll be launching two EC2 instance machine. One will name it as a Mumbai employee, other we name it as a US employee, okay. And we will try to write the code, upload the code. These all things we'll see flow by flow, okay. So till then, just practice it, all of it, okay. And in few minutes, I will upload the document. Or wait, let me just upload the document. Labs documents. Okay, so just give me a second. Okay, so I uploaded the document here in the document section. Okay, you'll be able to see here this one, model 6. So just go through this PDF file. This is a PDF file only we talked about. Okay, so just go through it, and tomorrow we'll start with the practical. Okay, any other thing, anything? Okay, thanks all of you. Have a nice day.
Yeah, thank you.